Hi, this is Kodanda Ramaiah, Faculty of Mathematics. Today, we are going to discussing about one of the most important topic of matrix, that is Cayley-Hamilton theorem. So, Cayley-Hamilton theorem is one of the best method of finding the values. So, the statement of Cayley-Hamilton theorem, every square matrix satisfies its own characteristic root equation. So, that is, if A is a square matrix of order n, and modulus of A minus lambda I equals to A naught plus A1 lambda plus A2 lambda square plus and so on plus AN lambda power n. Then A naught I plus A1 A plus A2 A square plus and so on equals to 0. This is the statement of the Cayley-Hamilton theorem. So the characteristic, another form of the characteristic root equation is lambda cube minus S1 lambda square plus S2 lambda square minus S3 equals to 0. Here, S1 equals to sum of the principal diagonals, S2 equals to sum of the determinant of each principal diagonals, and S3 equals to determinant of the given matrix. So that is another form of the characteristic root equation. By using Cayley-Hamilton theorem, we can find out also inverse and power of the matrix. Power of the matrix means A power 4, A power 5, A power 6 like that. Inverse of the matrix A power minus 1, A power minus 2, A power minus 3 also. How to find out the inverse and power of the matrix? By using Cayley-Hamilton theorem. So we can obtain the inverse and power of the matrix by Cayley-Hamilton theorem. Let capital A be the any square matrix, then the characteristic root equation is lambda cube minus 3 lambda square minus 3 lambda plus 9 equals to 0. So by using Cayley-Hamilton theorem, the lambda cube minus 3 lambda square minus 3 lambda plus 9 can be written as a cube minus 3a square minus 3a plus 9i equals to 0. So this is a characteristic root equation of in terms of A. So now we can find out inverse. That means multiplying inverse on both sides of in equation 1. So that implies a power minus 1 into a cube minus 3a square minus 3a plus 9i equals to 0. That implies a square minus 3a minus 3 plus 9 a power minus 1 equals to 0. The simplification of a power minus 1 equals to 1 by 9 into 3a minus 3i minus a square. So A matrix will be substituted here. I means identity matrix is substituted here. A square matrix is substituted here. And simplify this entire form, we get a power minus 1. That is inverse of matrix. And also we can find out a power 4. So that means already a cube, you can start with the equation. So that's why we need one more a. So that's why multiplying a on both sides. So that means a into a cube minus 3a square minus 3a plus 9i equals to 0. So that implies a power 4 minus 3a power cube minus 3a square plus 9a equals to 0. So a power 4 equals to 3a cube plus 3a square minus 9a. So this is the a power 4 term of the equation. And also by using this characteristic equation, we can find out a power 5, a power 6 also. So now we have to consider one of the example of that finding a power minus 1 and a power 4. So if a equals to any 3 by 3 matrix like that 1, 2, minus 1, 2, 1, minus 2, 2, minus 2, 1. So the characteristic root equation is modulus of a minus lambda I equals to 0. That implies modulus of 1 minus lambda 2 minus 1 2 1 minus lambda minus 2 2 minus 2 1 minus lambda equals to 0. The simplification determinant of this matrix is lambda cube minus 3 lambda square minus 3 lambda plus 9 equals to 0. That means a cube minus 3a square minus 3a plus 9i equals to 0. So multiplying a power minus 1 on both sides, a cube minus 3a square minus 3a plus 9i is a given characteristic root equation. So multiplying a power minus 1 on both sides. So that means that simplification is a square minus 3a minus 3 plus 9a power minus 1 equals to 0. So a power minus 1 equals to 1 by 9 into 3a minus 3i minus a square. So now we can substitute a matrix, identity matrix, and a square matrix. And simplification of these three terms, we get a power minus 1 equals to minus 1 by 9 into 303, 6 minus 30, 6 minus 6, 3. This is the final matrix of a power minus 1. And also we can find out power, a power term, a power fourth term. So already the given equation is in terms of a cube. So that's why we need one more a is here. So multiplying a on both sides. So that means a into a cube minus 3a square minus 3a plus 9i equals to 0. Multiplying that one means a power 4 minus 3a cube minus 3a square plus 9a equals to 0. A power 4 equals to 3a cube plus 3a square minus 9a. The simplification of this matrix is a power 4 equals to 972 minus 72, 081 minus 72, 009. This is the a power 4 term. And one more example of the Cayley-Hamilton theorem. The problem is verify Cayley-Hamilton theorem a power and also find a power 4 and a power minus 1 when a equals to 2 minus 1 2 minus 1 2 minus 1 1 minus 1 2. So the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equals to 0. This is another form of the characteristic root equation. Here s1 equals to sum of the diagonal elements. That means 2 plus 2 plus 2 equals to 6. Sum of the min terms of the main diagonal element, that is 3 plus 2 plus 3 equals to 8. And S3 equals to determinant of the given matrix is 3. Substitute A, S1, S2, S3 values in this equation 1. So that means that equation can be written as lambda cube minus 6 lambda square plus 8 lambda minus 3 equals to 0. So by using Cayley-Hamilton theorem, the lambda cube in terms of lambda equation will be converted to a cube minus 6a square plus 8a minus 3i equals to 0. So we need for this equation a square and a cube here. So that's why if we can find out a square, that is a square equals to a into a, the product of these two matrix equals to 7 minus 6 9 minus 5 6 minus 6 5 minus 5 7. And also we can find out a cube. A cube equals to a square into a. So already a square is done. A square into a matrix, we get this matrix, that is 29 minus 28, 38 minus 22, 23 minus 28, 22 minus 22, 29. So substitute all values, that is a cube minus 6a square plus 8a minus 9i equals to, this is a cube matrix, this is 6a square matrix plus 8a matrix minus 3 into identity matrix. The simplification of these four matrix we get equals to 0. So a cube minus 6a square plus 8a minus 3i equals to 0. Hence verify the Cayley-Hamilton theorem. After verifying the Cayley-Hamilton theorem, we can find out a power 4 and a power minus 1 by using Cayley-Hamilton theorem. So how to find out a power 4 and a power minus? To find a power 4. So the given characteristic root equation is a cube, starts with a cube. So we need one more a for this characteristic root equation. So that's why multiplying a on both sides of in this characteristic root equation, that equals to a power 4 equals to 6 into 6a square minus 8a plus 3i minus 8a square plus 3a. That simplification is a power 4 equals to 28a square minus 45a plus 18i. 28 into a square, already a square is done. So that means a power 4 equals to 28 into a square matrix minus 45 into a matrix plus 18 into identity matrix. The simplification of these three matrix equals to 124 first row of the minus 123 162 minus 95, 96 minus 123, 95, 95, 124. So this is the A power 4 matrix of by using the Cayley-Hamilton theorem. And also by using Cayley-Hamilton theorem, how to find out A power minus 1. So that means A power minus 1 multiplying in this given characteristic root equation. So that implies A square minus 6A plus 8I minus 3A power minus 1 equals to 0. So 3A power minus 1 equals to A square minus 6A plus 8I. So 3A power minus 1 equals to A square matrix minus 6 into A matrix plus 8 into identity matrix. So simplification of these three matrices, we get A power minus 1 equals to 1 by 3 into the first row of the matrix 3, 0, minus 3, 1, 2, 0, minus 1, 1, 3. This is the A power minus 1. So by using Cayley-Hamilton theorem, we can find out A power minus 1, A power minus 2, A power minus 3 also. So this is one of the most important method of the Cayley-Hamilton theorem for the matrix. Thank you.